Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. So, students, I welcome you all to your Nexus Batch, and today we are going to start with our lecture number 2 based upon your chapter Chemical Bonding. So, students, in your class 11th till now, we have covered periodic classification and the periodic properties. And we have initially started the chapter chemical bonding. In the previous session, we took a general introduction with regard to the modes of chemical bonding, that how do chemical bond formation occurs. Or I would say that basically there were two steps we thought over there. The initial one was by sharing of electrons. The another one was by transferring of electrons. So we studied these two concepts in detail with some examples. Now we are going to move, forward with a new topic in our session today. That is going to be Lewis dot representation, Lewis theory, and it is very, very interesting. Also, students, we are going to calculate the formal charge on the particular atom. So how to do that, ma'am, and how we are going to proceed? So let us start this with a beautiful smile. So students, as I've already told you, this is going to be our lecture number 2 for today's class. So what are the topics, or what is the today's target that we have to complete? So the very first thing that you need to do over here is, initially we will be understanding about Lewis theory. Okay, or Lewis dot theory you can say. Then we will be understanding about Lewis dot structure. Further, students, we shall be understanding about the formal charge, and at last we also will be reading from the NCERT highlight. So you very well know, with regard to inorganic, I have already told you in all your classes that NCERT highlight is really very important. Now, what is NCERT highlight? If you're new to this session today, or if you're new to your Nexus batch, let me tell you, students, in NCERT highlight, I just bring out the important key points from the NCERT itself, so that if you're not reading NCERT, if you're not going through the NCERT, you can cover it over here in the session only. There is no need to even read NCERT again if you are doing NCERT highlights from here, because we are taking important key concepts, important key points, NCERT in-text question, NCERT back exercises over here itself. Yes, everyone. So now, starting with the very first topic, I am introducing you again with your friends, barium and calcium. So calcium is saying, hello, my shimmering stars. Have you revised yesterday's session? While barium says that, hi friends, be ready for this new chapter, be ready for this new topic today. So they are welcoming you again in your Nexus batch, students. Yes? Okay. So now, starting with the very first part of ours, that is Lewis dot structure. Okay. So now, one by one, we will be understanding about in detail. First of all, let us see. Lewis theory, or Lewis dot theory, basically is used for covalent compounds. It is used to represent them, that how do they look alike, what are the structures, how do you represent covalent compounds. So for that we are going to use the Lewis dot theory. Now, how to draw Lewis dot structure? This is the initial topic that will lead further on to the octet rule. What are the limitations of the octet rule? But before that, we need to understand about Lewis dot structure. Now, what it is exactly, ma'am? How you have to calculate it, ma'am? Lewis dot representation or Lewis dot structure is something, for example, you have a single element or a single atom. Let us consider if you have hydrogen. How you're going to represent that hydrogen? With the help of dots. The dots word over here represent the valence electrons. What are the valence electrons now? Valence electrons are those electrons which are found in the outermost shell. What are valence electrons? Those electrons which are found in the outermost shell. So valence electrons basically are used in the formation of the covalent compounds, are used in the formation of bond. So see, valence electron in the formation of molecule, only the outer shell electron take part in chemical bond, and they are known as valence electrons. Valence electrons. Let us take a general example of sodium. Sodium has an atomic number 11. Now you very well know the electronic configuration. It is going to be, ma'am, 1s2, 2s2, 2p6, 3s1. Yes. So what is the outermost shell? Let us draw this. Let us draw this. This is your nucleus. This is your first shell, second shell, third shell. See, here you can clearly observe it is your first shell, second shell, third shell. First shell contains 2 electrons. Second shell contains 2 plus 6, 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And third shell contain only 1 electron. So what are valence shell over here? Valence shell are those electrons which are present in the outermost shell, or the shell which is the last shell. So over here you can see that there is 1 electron in the outermost shell. In the outermost shell, so valence electrons in the case of sodium comes out to be how much? 1 electron, ma'am. Clear? Very easy. Let us take some more examples. Now I am calculating the number of valence electrons. Let us take an example of carbon. Also, let us take one more example of nitrogen. See, nitrogen basically has an atomic number 7, students. So what is going to be the electronic configuration? Ma'am, it is 1s2, 2s2, 2p3. Count the electrons. 2 plus 2, 4. 4 plus 3 is 7, right? Now, we have to represent it. So, this is going to be nucleus, your first shell and your second shell. Yeah, only 2 shells are there. Now, see, first shell contains how many electrons over here, ma'am? Only 2 electrons. Only 2 electrons. Second shell contains 2 plus 3. That is 5 electrons. So, 1, 2, 3, 4 and 5. So, outermost shell is second shell and it contains 5 electrons. So, what is going to be the valence electrons over here? 5. What are the valence electrons? 5. Let us take case of carbon now. Carbon has an atomic number 6, students. So, you have to write the configuration 1s2, 2s2, 2p2. Yes, 2 plus 2 plus 2, that comes out to be 6. No, 2p2. Now, let us draw this. This is your nucleus, first shell, second shell. First shell contains how many electrons, students? Ma'am, 2 electrons. Second shell contain how many electrons? 2 plus 2, 4 electrons. So, it is going to be 1, 2, 3 and 4. That means outermost shell over here contains 4 electrons. So, this is going to be your valence electrons. Now, you very well know what are valence electrons? Yes? Okay. Let us take one more case and then I guess valence electrons concept is quite clear to you. So, one more key concept of oxygen atom. Oxygen atom has an atomic number 8, right? What is going to be the configuration? 1s2, 2s2, now 2p4. 2 plus 2 plus 4 comes out to be 8, no? So, if I have to make the structure, nucleus, first shell, second shell. See, count the electrons now. How many in first shell, ma'am? 2. How many in second shell? 2 plus 4. That means 6 electrons. So, 1, 2, 3, 4, 5, 6. That means outermost shell contains 6 electrons. So, ma'am, this is your valence electrons. These are your valence electrons. Now, I guess you very well know what are valence electrons. Yes, everyone. Yes, everyone. Please write it down so that I can now move on to the next part. Everybody write it down so that I can now move on to the next part. Shall we move on to the next part, everybody, if it is written? Done, students? I have just separated it so that you can't, mix it all together. Done, everybody? So, these was all about valence electrons. The calculation of valence electrons. Clear, everyone? Now see, students, the next important key concept, Cossel and Lewis approach chemical bonding, or in other words is Lewis theory or Lewis dot theory, or in other words is Lewis theory or Lewis dot theory. Let us understand this. Lewis octet rule. Now what is octet? Octet basically refers to 8 electrons. What is octet? Octet basically refers to 8 electrons. In some of the cases you will see duplet. Duplet basically is 2 electrons. I'm mentioning it also over here if you don't know. Duplet basically is 2 electrons. Duplet basically is 2 electrons, and let us write octet also over here so that you can write each and every key concept. Octet basically is how many electrons, ma'am? 8 electrons. How many electrons? 8 electrons. Right, now come back to this. Cossel and Lewis approach chemical bonding. What does it states that? It states that Lewis octet rule. Every atom has a tendency to attain noble gas electronic configuration. What are the noble gases? What are the noble gases? Group number? Which group? Group number 18. Which group? Group number 18. Yeah. So each and every element, you know, students, in the complete periodic table, what it wants? It wants to be stable. It wants to attain the electronic configuration, right? So for maximum stability, in order to attain it, it is going to acquire which configuration? The configuration which group number 18 elements hold. Clear? Now see. That means to have 8 valence electrons. So Lewis octet rule, octet here refers to 8 electrons. So each and every element will have a tendency to acquire 8 electrons in its outermost valence shell. Now valence shell you very well know, and this is the theory which is given by the Lewis and Cossel approach chemical bonding. So Lewis and Cossel. Yeah. So now everybody, have you written this? I'm getting a side. See, each and every key concept I'm mentioning over here, you have to mention it in your notebooks also. In your books also, you have to write down. Moving on to the next part, students, now. Rules to write down the Lewis dot structure. What are the rules to write down the Lewis dot structure? Very interesting segment, a very important segment. Let us start with the very first rule. Very first rule is calculate the total number of valence electrons available for bonding in the given molecule. Okay, now let us calculate some of the examples by doing each and every one of that. So, calculation of valence electrons. We are starting with this part. Now this in molecules. Now only we have calculated the valence electrons in some of the cases though. But over here, students, I am going to calculate the valence electrons in the case of molecules. So let us see first of all. One by one we are going to calculate. So I am starting with, let us write ABC. That will be much better. No? So the first part that we are going to start with is H2. For the case of H2 molecules, how you have to calculate? That is, see, how many hydrogen? 2. So here calculate total valence electrons. Total valence electrons. How many hydrogen, ma'am? 2. So 2 into, now 2 into valence electrons of single hydrogen, because there are 2 hydrogen, right? Now 2 into, what is the valence, valence electrons of, in the case of hydrogen? See, students, hydrogen has atomic number 1, so electronic configuration 1 is 1. That means 1 electron is seen in the outermost shell. So valence electron in the case of hydrogen is only 1. Yeah. So 2 into 1 comes out to be 2. That means 2 electrons are the total valence electrons that are seen in the case of H2. That are seen in which case, students? That are seen in the case of H2. Clear, everyone? Everyone write all of these over here. One by one we are going to move on to the more examples. Just keep on writing these. Just keep on writing this. Now taking another example. Just taking another example. That is that is part B. Let us take in case of CH4 molecule. Now in the case of CH4 molecule, just see. Total valence electrons is equivalent to what? How many electrons? How many carbon? 1. So 1 into carbon valence electrons plus 4 into hydrogen valence electron. How many valence electron are seen in the case of carbon? Now only we have calculated it over here. How many electrons were seen in the case of carbon, ma'am? 4 valence electrons. How many? 4. Plus 4 into how many valence electrons in the case of hydrogen? 1. So this comes out to be 1 into 4 is 4 plus 4 into 1 is 4. That means total 8 valence electrons are seen over here. That means total 8 valence electrons are seen over here. Clear, everyone? Is it clear to everyone? Write it down, students. This we are calculating the total valence electrons. This we are calculating the total valence electrons over here. Calculation of valence electrons. Let us take more cases now. Shall we? Okay. Now see, students. Here I am explaining you a case which carries a negative charge. Let us take a case of NO3 negative. NO3 negative or NO3 minus 1 it would be written. Now see. Total valence electrons or total electrons, total valence electrons I am talking about. It is equivalent to how many electrons are seen in the case of nitrogen. Now only we have calculated 5 valence electrons. 5. Plus for oxygen, how many it will be? For oxygen it will be 6. For oxygen we have not calculated. I will calculate it over here only. Calculating for oxygen atom, okay? Oxygen atom has an atomic number 8. So it is 1s2, 2s2, 2p, 4. 4 plus 4, 8. I don't know. I guess we have done. Yeah, we have done for oxygen. Sorry. 6 electrons, no? So I am just clearing it out. Yeah. 6 electrons. Now how many oxygen? Ma'am, 3 oxygen. Minus 1 is written, so you have to write plus 1. If it is written minus 1, always remember, if it is written minus 1, that means you have to do plus. If it is written plus 1, you have to do minus. Clear? Now see. So this comes out to be 5 plus 18 plus 1. That means it is 24 electrons. How many valence electrons? 24 valence electrons. Clear, everybody? First of all, write this down. Let us take one more case now. Yeah, let us take another case. D part, NH4 positive. So total valence electrons is equivalent to, for the case of nitrogen, how many total valence electrons were there? Ma'am, 5. 1 nitrogen, so 1 into 5. Plus for hydrogen, how many valence electrons? 1. Total hydrogen 4, 1 into 4. Now it is written plus 1, so you are going to subtract it. You are going to do what? You are going to subtract it. So what it will be? 5 plus 4 minus 1. That means how many electrons? 8 electrons. Clear, everyone? Everybody please write it down. I am doing from very basic key concept, students. I am taking very basic key concept. Clear? Clear, everyone? Yeah. So this was all about the calculation of valence electrons among all of these. So we have calculated valence electrons. The very first rule was calculate the total number of valence electrons available for bonding in a given molecule. Now for an ion, that means which carries a negative charge, add electrons equal to the charge in the valence electrons of an atom. For an ion, that means the one which carries a negative charge, you have to add it. When there is a positive charge, you have to subtract it. That means for cation, remove the electrons. Clear, everybody? And then example they have given you for the case of NH4 positive. Now only we have calculated. See, for the case of NH4 positive, it comes out to be how many, ma'am? 8 electrons. How many, ma'am? 8 electrons. Yes, everybody, please write it down, students. Done, done, done. That's great. Moving on to the next part, students. Next rule to write down the Lewis dot structure basically is what? See, least electronegative polyvalent atom occupies the central position. Now see what happens. Let us take a case of NF3. Okay. Now, how do you know which atom is going to acquire the centralmost position? Okay, now many of you may write it as nitrogen, fluorine, fluorine, fluorine. Many of you may also write it as fluorine, 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 nitrogen. Which of the following structure is right one? How do you know that, ma'am? How we can know that which of the following structure is the correct one? Let me tell you, this structure is going to be the correct one and this structure is going to be the incorrect one. But what is the reason, ma'am? What is the reason? Reason is least electronegative polyvalent atom will acquire the centralmost position. Always remember that. Okay, and if it doesn't occur over there, what rules you have to keep in mind? That is least number. First part is least number. See which of the following element is present in least amount. Here nitrogen is 1, fluorine is 3. Nitrogen is in least amount, so can acquire centralmost position. If this number is also equal, then you can go for what? You can go for least electronegative. Then you can go for what? Least electronegativity. Now you have understand electronegativity in depth. What actually is electronegativity? You have understand it. It is tendency to attract shared pair of electron towards itself. If you are not getting this as well, then you will move on to the factor that is size largest. Which of the following structure has the largest size? Not the structure, sorry, the element, the atom, which has the largest size will acquire the centralmost position. And the last is, if it doesn't follows as well, you can go with atomic number largest. So this is basically the rule number second, which is modified further. Least number, then least electronegativity, then size largest, then atomic number largest. Do remember this, students. Clear, everybody? Clear? Now the next part. Show shared pair of electrons between two atoms and unshared electrons on one atom. Okay, so this is how you represent. Now only we are going to start it, so no need to worry about it. But yes, first of all, write all these rules down. Then I'm going to bring you some questions over here. So students, I guess everybody has written these rules, right? Now, let us proceed further. We are going to now calculate the formal charge and also how to represent the structure. First of all, we will represent the structure. We will take some cases and then we will start with the topic formal charges. Clear, everyone? So starting with the very first structure, let us do now the Lewis dot representation, everybody. Let us start with Lewis dot representation, students. Let us start with Lewis dot representation, everybody. So starting with the very first part, that is H2 molecules. Now before this, students, let me tell you, I have told you to calculate number of valence shell. How you have to represent this, okay? Representation of elements. Here I am doing representation of elements, and then we will be looking up to the formation of a chemical bond over here in the case of molecules. So first of all, I am taking the case over here, that is representation of elements. In the case of, let us consider hydrogen. Let us consider we have to represent hydrogen. How we will represent? We have to show the total number of valence electrons. The total number of valence electrons is 1. So you will represent hydrogen and then 1 electron. Clear? Now let us take another case. For example, helium. We know the total number of valence electron is 2. So how you are going to represent helium as 1 and 2. Okay, now for lithium, how many valence electrons? Lithium has an atomic number 3. So it is 1s2, 2s1. Valence electrons is 1. What is valence electron? Electron in the outermost shell. First shell, second shell. First shell contain 2 electrons, second shell contain only 1. So 1 is the valence electron. So lithium can also be represented as like this, Li, then dot. Clear? Dot represents the total number of valence electrons. Now moving on to the fourth one. Let us take one more case. Let us take a case of carbon. Carbon has an atomic number 6. So its configuration is 1s2, 2s2, 2p2. How many valence electrons? 4 valence electrons, no. So you will represent carbon as 1, 2, 3 and 4. Getting my point, everybody? Getting my point? Is it clear? Now see, Let us take few more cases. Let us take in case of nitrogen. Nitrogen atomic number 7. What is the configuration? 1s2, 2s2, 2p3. How many electrons in the valence shell? 2s2, 2p3, 5 electrons. If you don't understand by this way, you can draw also. First shell, second shell. First shell contains 2 electrons. Second contains 1, 2, 3, 4 and 5. So outermost shell contains 5 electrons. That means you have to represent it by 5. So 1, 2, 3, 4 and 5. Yes, simple. Let us take a case of oxygen. Oxygen has an atomic number 8. So it is 1s2, 2s2, 2p4. How many valence electron? 2 plus 4 is 6. 6 valence electrons. So oxygen is 1, 2, 3, 4, 5 and 6. Clear everyone? This is the way to represent for oxygen atom. Let us take case of chlorine. No, let us take a case of fluorine. Fluorine basically has an atomic number 9. So 1s2, 2s2, 2p, 5. How many valence electron? 2 plus 5, that is 7 electrons. So fluorine will be represented as 1, 2, 3, 4, 5, 6 and 7. Clear everyone? Let us take case of sodium. Sodium has an atomic number 11, students. So how you are going to represent it? It is 1s2, 2s2, 2p6, 3s1. Third shell is the outermost shell. How many valence electrons, ma'am? 1 valence electron. So sodium will be represented as like this. Yes. Let us take the case of magnesium now. Magnesium has an atomic number 12. How it will be represented? 1s2, 2s2, 2p6, 3s2. That means how many valence electrons? 2 valence electrons. So 2 valence electrons. Let us take one more case. Aluminium. Aluminium atomic number 13. 1s2, 2s2, 2p6, 3s2, 3p1. Simple, no? Now see. That means how many electrons in the valence shell? 3. Clear? By this way. So by this way you represent elements. Okay, this is the Lewis dot representation of elements. Clear? Now we are going to start with the representation of molecules. I would request each and everybody of you to please kindly write down all of these over here. Write down all of these over here. Clear? Clear. Okay, now moving on to the representation of molecules. Representation of molecules. Let us start with, now we have done till J part, no? So this is going to be K part. H2. We are going to start with H2. Now see, the very first thing that you need to do is, very first rule is calculate total valence electrons. Calculate total valence electrons, right? So, total valence electrons is going to be how much? There are 2 hydrogens, so 2 into valence electrons of single hydrogen. Now what are the valence electrons of hydrogen? 1. So 2 into 1 is 2 electrons. This is total valence electrons you have calculated. What you have calculated? Total valence electron. Now see, you are going to create a bond. See, there are 2 hydrogen, write 2 hydrogen. And they will contain at least single bond. Initially create a single bond and then calculate bond pair electrons. What I said you? Initially create a single bond, then calculate bond pair electrons. Now what is a bond pair electrons? What are bond pair electrons? Bond pair electrons. Bond pair electrons are those electrons which are basically present in a bond. For example, single bond contains how many electrons? Always see, single bond holds 1 and 2 electrons. Now, double bond contains how many electrons? See, it is going to be 1, 2, 3 and 4. 4 electrons. Now, what about triple bond, students? It is 1, 2, 3, 4, 5 and 6 electrons. Single bond contain 2 electrons, double will contain 4 electrons, triple will contain 6 electrons. So these are bond pair electrons. How many electrons are present in a single bond over here? So initially what we have to do is, initially we have to create a single bond. Now only a single bond. Then you have to calculate bond pair of electrons. Now you have represented a single bond. How many bond pair electrons, ma'am? Bond pair electrons, there is a single bond, so 2 electrons. Now calculate lone pair electrons. Lone pair electrons. How you will calculate it? You will calculate lone pair of electrons as total valence electrons minus bond pair electrons. Total valence electrons minus bond pair electrons. What are total valence electrons? 2. What are bond pair electrons? 2. So lone pair comes out to be 0. That means they have no extra electrons present over there. That means this structure is complete. Now let us show the Lewis dot representation. See, this is first hydrogen, this is second. The first hydrogen will show 1 electron. This is the representation, right? Now what are they doing? They are sharing their electrons. They are creating a bond with this electrons. So when a bond is created, this hydrogen now acquires 1 more electron, and this hydrogen also acquires 1 more electron, creating a bond. Now see, this hydrogen has 2 electrons in the outermost shell. Initially, hydrogen had 1s1 configuration. Now there is 1 more electron with it, right? So it becomes 1s2. This hydrogen also becomes 1s2. That means it completes its duplet. So it is stable now. And this is the structure. Also, there is 0 lone pair of electron. That means no extra electrons over here. Hence, this structure is the correct one. What are lone pair of electrons? The extra electrons which don't participate in bonding. Lone pair electrons or LP electrons which don't participate in bonding. Clear, everyone? Is it clear to each and everyone? Now this was the structure of H2. Everybody write it down so that I can draw the next structure of ours for now. Now you are going to draw for NF3. Everybody done? Done. Okay. Now we are going to do with the part number JKL, L part, and we are going to draw NF3. Calculate total valence electrons, everybody, first of all. Total valence electrons. So for nitrogen, how many valence electrons, ma'am? 5. For fluorine, how many valence electrons, ma'am? 7. How many fluorine? 3. So this comes out to be 5 plus 21. That means, ma'am, 26 electrons. 26 valence electrons. Now show single bond in each and every case. Now which is going to be the central metal atom? Nitrogen, because it has least electronegativity. Secondly, it has if you see the number, it has least number. So nitrogen will be the centermost, and then will be fluorine over here, fluorine over here, fluorine over here. So how many bond pair electrons you have represented? 1, 2 and 3 bonds. 3 bonds into each bond contain 2 electrons. So this comes out to be, ma'am, 6 electrons. 6 bond pair electrons are seen in this case. Now calculate lone pair electrons. Lone pair electrons, ma'am, is total valence electrons. Total valence electrons minus bond pair electrons. Yes. So total valence electrons is 26 minus the bond pair electrons. This comes out to be 20 electrons. How many lone pair electron? 20. Now let us represent it. See, nitrogen has how many valence electrons in the outermost shell? 5. So represent 1, 2, 3, 4 and 5. Yes. Now comes for fluorine. How many valence electrons in fluorine? 7, ma'am. So this is first fluorine. 1, 2, 3, 4, 5, 6 and 7. The next fluorine. 1, 2, 3, 4, 5, 6 and 7. Another fluorine. 1, 2, 3, 4, 5, 6 and 7, ma'am. Yes. Yes. Now students, let us check the number of electrons they are holding. See, fluorine has 7 electrons and is gaining 1 electron of nitrogen. Total 8 electrons. Total how many, ma'am? 8 electrons. Now see this. 7 plus 1, 8 electrons. 7 plus 1, 8 electrons. Let us talk in the case of nitrogen now. See, nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen with also 8 electrons. 8 electrons, right? Now let us see they are completing its octet, 8 8 8 8 electrons, but let us see this over here. There are total 20 lone pairs. Let us count lone pair electrons now. See, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. You have to count those electrons which are not participating in bonding. Lone pair electrons are those electrons which don't participate in bonding. So there are 20 lone pair of electrons hence found. Now there are some more rules that you should know, that if positive charge is written on any compound, on any molecule, is written on molecule, it is present at central metal atom. Central metal atom. Okay, and if negative is written, it is present on terminal atom. It is present on terminal atom. If positive is written, it is present on the central metal atom. If negative is written, it is present on the terminal atom. You will get to know in the upcoming examples. But yes, do write it down, everybody. Also, there is one more key concept, that central metal atom can have more than 8 electrons also. But yes, their initial rule, the initial rule of the representation of molecules over here, or of the octet rule, Lewis octet rule, is to complete its octet. Right? For example, fluorine is completing its 8 electron, nitrogen is doing that, another fluorine, all of them is to attain stability in order to gather 8 electrons in the outermost shell. Yes, everybody write it down so that I can move on to the next slide, students. Now we are going to take the next case. So the next case, that is M case, we are going to start, is going to be about NH4 positive. Shall we start with NH4 positive? Now see, calculate total valence electrons initially. Total valence electrons. So for nitrogen it is 5. For hydrogen it is 1. Total 4 hydrogen. If plus 1 is written, you have to subtract 1. Right, guys? So it is 5 plus 4 minus 1. That is 8 electrons. How many electrons, ma'am? 8. Next step, to show single bond. Now nitrogen, hydrogen, hydrogen, hydrogen. It has least number, nitrogen has, so it will be central metal atom. Now, count the bond pair electrons, everybody. How many bonds, ma'am? 4 bonds. Into 1 bond holds 2 electrons. So, ma'am, 4 into 2 is 8. That means bond pair electrons is 8 electrons. Now, let us see the lone pair electrons. Lone pair electrons, what it is? Total valence electrons minus the bond pair electrons. Total valence electrons minus bond pair electron. How many valence electron, ma'am? 8. Minus bond pair. How many it is? 8 electrons. So this comes out to be 0. That means there is no lone pair. So yes, it does not contain any lone pair of electrons. Next part. Many of you will say that, ma'am, now let us draw the structure completely. Nitrogen basically has, 5 electrons in the outermost shell though. Yeah. And hydrogen also has 1 electron. Let us see it over here only. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Completing its octet. Even hydrogen are completing its duplet. So, but what about this positive charge? Where we have to represent this positive charge? You have to represent this positive charge at the central metal atom. Already told you in the previous slide, students, that if positive charge is written on the molecule, it is present on the central metal atom. If negative charge is written over there, it should be represented at terminal atom. So positive charge will be represented at central metal atom. Clear? So I have represented it over here. Clear, everyone? Shall I move on to the next part? Yes, everybody, be fast. Now starting with the next part. N part. N part is O2 molecule. Right? Let us calculate total valence electrons. Let us take another color, no? So, total valence electrons, how many oxygen? 2 into valence electrons of 1 oxygen. So 2 into how many valence electrons are seen in the case of oxygen atom? Ma'am, 6. Now only we have calculated, no, 6 electrons. So total comes out to be, ma'am, 12 electrons. Okay. Now show single bond initially between oxygen. What are bond pair electrons? Ma'am, bond pair electrons are only 2 electrons. So what will be the lone pair electrons? It will be total valence electrons minus the bond pair electrons. Now total valence electron is 12 minus bond pair is 2. This comes out to be, ma'am, 10 electrons. Let us represent them. Oxygen, each oxygen holds 6 electrons. So 1, 2, 3, 4, 5 and 6. Now 1, 2, 3, 4, 5 and 6. This is the representation. Now see whether its octet is complete or not. 1, 2, 3, 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6, 7. No. That means no. Ma'am, this is incomplete. That means, ma'am, what we have to do? How we have to represent it? This is the not correct one. So see, it is oxygen 1, 2, 3, 4. Oxygen has 1, 2, 3, 4. Single bond was already seen over here. Now 1 electrons are left. 1 electrons more will create one more bond, that is double bond. So it is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That means this is the right way. This is the right way. In order to create a bond, everybody first draw the structure. Draw the structure. See, octet was not completing. Octet was not completing, guys. Yes. In this way, octet was not completing. 7 electrons, not 8. Over here, see, 1, 2, 3, 4, 5, 6, 7, 8. Now see, 1, 2, 3, 4, 5, 6, 7, 8. 8 octets were completing. That means this structure is now complete. That means oxygen molecule holds double bond. It holds double bond. Now check lone pair of electrons. Are there 10 lone pair of electrons still present? 1, 2, 3, 4, 5, 6, 7, 8. Why? Because now bond pair electrons get changed. Bond pair electrons are now 4. So lone pair electrons comes out to be 12 minus 4, that is 8 electrons. So yes, we have drawn the correct structure now. So by this way, you know how a single bond is created, how a double bond is created. Yes, students, everybody write this down. Done, done, done. Shall I move on to the next case? Yes, shall I move on to the next case? Now we are going to take the case of NO3 negative. I'm moving on to the next slide. MNO. Now we are moving on to the O part. NO3 negative. First of all, students, you have to calculate what? Total valence electrons. Total valence electrons is nitrogen holds 5, oxygen holds 6, total 3 oxygen. Now it is negative charge, so you are going to add 1. So this is 5 plus 18 plus 1, that means it is 24 electrons. Now the next part over here is what? Next part is to draw the structure. Nitrogen holding 3 oxygen atoms. Yeah, so the bond pair of electrons you are writing over here is 3 bonds into 1 bond contain 2 electrons, so 6 electrons. What will be the lone pair electrons, ma'am? It is total valence electrons. Total valence electrons minus the bond pair electrons. Now see, total valence electron is 24 minus bond pair is 6, so this comes out to be 18 electrons. Now we have to represent the structure. See, nitrogen basically holds 5 electrons, 1, 2, 3, 4 and 5. Now let's talk about the case of oxygen. Oxygen holds 6 electrons basically. So 1, 2, 3, 4, 5 and 6. Similarly, this oxygen 1, 2, 3, 4, 5 and 6. Now this oxygen 1, 2, 3, 4, 5 and 6. Now they are creating a single bond over here. Nitrogen, if I talk about 1, 2, 3, 4, 5, 6, 7, 8 is stable, but oxygen is still not stable. So what will happen over here? This structure, that means, is incorrect. So nitrogen again holding 1, 2. See, nitrogen, let us talk about. Here will be double bond between oxygen atoms. Now see, 1, 2, 3, 4, 5, 6 and 7, 8. 6 oxygen atoms and twice of nitrogen holding. Another with single bond with oxygen atom. Single bond with oxygen, oxygen atom. Everybody first of all draw this, then I will explain you this part. Everybody draw the structure, then we are going to explain this part over here. Everybody draw the structure, then we are going to explain this part. Now see students, here you will say that they hold 7 electrons, ma'am. How you are going to explain this concept? With the help of this negative charge. See, till here if you're drawing, you will get confused. Why? Because now you will count the electrons in the outermost atom, that is oxygen, oxygen and nitrogen. They won't be equal to the octet rule. So how you're going to explain this concept? With the help of formal charge. Now we will be introducing with the term formal charge, and with the help of formal charge I will let you know that how students we do make the structures of the Lewis dot structure. Yes, Lewis dot structure, in the case of negative charges, we have to see the formal charges on individually each and every atom. Here we have 3 oxygen atom, 1 nitrogen atom. When you will calculate formal charge, it will justify your structure. But till then, it won't justify your structure. You will feel like, no ma'am, it's not completed octet, that means it's not right one. But yes, after knowing that part, you will get to know it. Yes, students. So now we are going to start with the formal charge. What is the formal charge? What actually is formal charge? So formal charge is the charge that is present on a particular atom. The charge that a particular atom carries is referred to as the formal charge. Okay, students. Now, how to calculate? What are the rules to calculate formal charge? See, formal charge in an atom in a polyatomic ion or compound can be defined as formal charge in an atom in a Lewis structure. Now, we don't have to calculate formal charge on complete molecule. No. Formal charge is used for a single atom. Right? Now, see. You have to calculate total number of valence electrons in free atom. Now, if you are calculating a formal charge for a single atom, for example, in NO3 negative, I will talk you about to calculate formal charge in case of nitrogen. That means the value you will put over here of total valence electrons will be of nitrogen, not of the complete molecule. Till now, we were calculating total valence electrons in order to know the structure. But for the cases which have a negative charge or a positive charge, in that cases, to calculate formal charge, take the valence electrons of a particular atom. Now, minus total number of non-bonding electrons. That means you have to subtract lone pair of electrons, complete lone pair of electrons, and then subtract total number of bonding, half into total number of bonding electrons. That means bond pair electrons. So, in simple terms, I would say that what you have to do is take valence electrons. You have to represent valence electrons by Q symbol, okay? Minus the lone pair of electrons, minus bond pair electrons by 2. This is the formula to calculate what, ma'am? To calculate formal charge. To calculate what, ma'am? To calculate formal charge. No need to worry the case of previous example, the O example. We will do it again. But first of all, we will calculate the formal charge. Everybody do write this formula, very, very important. Formal charge is equivalent to total valence electrons minus lone pair electrons minus the bond pair electrons by 2. Now students, more things about over here. Lewis structure which has the smallest formula charge in each atom is most stable structure. Do remember that. Also, sum of all the formal charges on an atom will be equal to 0 or the overall charge for a polyatomic ion. See, in redox reaction chapter, you will understand about oxidation state, the formal charge in detail. But always remember, when you are adding all the formal charge of all the atoms, its sum will be equal to 0. But yes, if it is not a neutral molecule, either a positive or a negative one, the sum will be equivalent to that number. Yeah? Okay. So now, this is your first homework question for your today's class, students. Question number first as a homework. You have to calculate the formal charge for the case of H3PO4. Here, calculate the formula charge for P. Now, what formula? Total valence electrons of P minus lone pair on P minus bond pair by 2. First of all, draw the structures just as I have told you. Calculate total valence electrons on the complete molecule, then make a single bond, then find bond pair electrons, then draw the structure, and then calculate the formal charge. So first homework question for today's segment that we are going to discuss in next class also. Second homework question for today's class is to calculate formal charge on pH3. On pH3, in the case of pH3, calculate on all the atoms, phosphorus and hydrogen. Clear? Yes. Now let us read the NCERT highlights, students. Yes, to make your concepts more stronger than before. Now see, Lewis pictured the atom in terms of positively charged kernels. Kernels are the positively charged species. The nucleus plus the inner electrons. Okay. And the outer shell that could accommodate a maximum of 8 electrons. He further assumed that 8 electrons occupy only the corners of a cube which surround the kernels. Thus, the single outer shell electron of sodium would occupy one corner of the cube because sodium contains one valence electron. No? While in the case of normal gases, all the 8 corners will be occupied because normal gases contain 8 valence electrons. Now, this octet of electron represents a particular stable configuration. So, octet rule is basically when you are gathering a electronic configuration of group number 18 elements, that is the stable electronic configuration. Lewis postulated that atoms achieve the stable octet when they are linked by chemical bonds. Yes? One more thing about Lewis symbols, what they have told you. In the formation of a molecule, only the outer shell electrons take place in the chemical combination. That means whensoever you are forming a chemical bond, only the valence shell electrons will form the chemical bond. Yeah, which are known as valence electrons. Now, the inner shell electrons are well protected and are generally not involved in the combination process. So, inner shell electrons are not represented because they don't form any bond. The outermost shell electrons will create the bond. Now, J.N. Lewis, an American chemist, introduced simple notation to represent valence electrons in an atom. These notations are called Lewis symbols, which we have already done for hydrogen, helium, lithium, boron, carbon, nitrogen, oxygen. That is what is Lewis symbols. Clear, everybody? So homework I have already given you. Now students, we shall be meeting in the next class. I hope so this class was very helpful for you. So we shall be meeting in the next class. Till then, keep smiling, keep learning. Thank you so much, my dear students, and have a good day.